I'm saying that now we'll learn the formulas which is based on the rectifier. Okay. So first we'll have half wave rectifier and we'll have full wave rectifier. As I told you, full wave rectifier is divided into two categories. One is the center tap that is denoted by CT. Another one is the bridge type that is denoted by BT. Okay. So in this case, I'll tell you all the things in all the formulas in a single page. In half wave rectifier, tell me how many are the number of diodes where we can use. In the half wave rectifier, it is only one. Okay. In the center tap, we'll have two diodes, and in the bridge type, we'll use four diodes. Correct? Now, maybe then in the numerical, they can ask you the IDC. As you know, rectifier is a device which is used to convert AC to DC, right? So output is in the DC form, correct? So they can ask you that calculate the output current. So it's obviously understood that output is the DC current, means they are asking the DC current, IDC. Or they can ask you that average value of current, that is also equal to IDC. Okay. So we'll have different formulas for IDC, for half wave rectifier and for full wave rectifier. For half wave rectifier, formula is I max divided by pi, and for the center tap it's 2 I max divided by pi, and for the bridge tap it is also the same, 2 I max divided by pi. Okay. Some of the times the derivation also they can ask you in the paper for IDC and for every numerical. That I'll tell you. Okay, first we'll focus on the numerical because numerical is the important one. Got it? Next formula which you need to remember, that is IRMS. RMS is the root mean square value of the current. I think that you have learned in the BT also, right? So IDC is basically the output current which is in the DC form. IRMS is basically the AC current which is the input current. Or they can ask you the directly like input current, average value of AC current. Okay, IRMS. So we are having formula for that. For half wave rectifier it is I max by 2, and for the full wave rectifier it is I max by root 2. So in BET you have studied this formula, I max by root 2. Right? Right? Now in the next case they can ask you the PIV. PIV is the peak inverse voltage. Okay. Peak inverse voltage is like the maximum voltage at the inverse side, means peak is the maximum, inverse is like the opposite side, voltage is voltage. Okay. So peak inverse voltage is how much for the half wave rectifier? It's Vs maximum, like Vs maximum. No, it is plus Vs maximum. Maximum value it goes up to, and this would be minus Vs maximum. This is basically the AC supply voltage, right? So in the bridge type rectifier, in the center tap rectifier it is 2 Vs maximum, and in the bridge type it is again Vs maximum. See why it is different in center tap rectifier. Reason for this, remember I told you the center tap rectifier is like this. So we have done tapping in the center. So above one is also Vs max, below one is also Vs max. If we'll combine it, then it will become 2 Vs max, right? So that's why it is different for center tap rectifier. Got it? Okay, next we need to calculate VDC. DC, as you know, it's a output voltage, so we can represent it by the output voltage. And formula for that, as according to Ohm's law, V is equal to how much? I into R. So VDC, can we say that IDC into RL? RL is the load resistance, correct? So IDC value we already know. IDC was how much? I max by pi. So combined it, it would be the I max by pi multiplied by RL. This will become the formula. Okay, understood? Similarly, for this, the formula will become 2I max by pi into RL, and for this one, 2I max by pi into RL. Correct? Because I just simply substitute this value in IDC into RL. Now, the next case, we need to calculate the most important rectification efficiency. Okay, like rectification efficiency is 90%, they'll ask you in the numerical. So why they said rectification? Because it is basically based on rectifier and it's an efficiency. Do you know in general what is efficiency basically? Efficiency is basically output divided by input. Okay, like suppose you have studied 5 question, and in the exam also that from you will be able to do 4 question. Okay, so how much is your efficiency? 80%, right? So you have done output divided by input. So in this thing also we'll do the same. So we'll have particular formula for the rectification efficiency. For the full wave rectifier, it is same for both the cases, that is 0.812 divided by 1 plus 2 into RF divided by RL. What is RL over here? RL is the load resistance. Okay, and what is RF over here? RF is the diode resistance. If they have mentioned diode resistance in the numerical, then only we need to consider it. Otherwise, we can take diode resistance as 0. Okay, so like 80% of the time they didn't mention, but if they mention, we have to consider it. It is the same formula for the both the cases. Okay, now for the half wave rectifier, the formula for the efficiency is 0.406 divided by 1 plus RF divided by RL. Okay, and as you know, efficiency must be in percentage, so multiplied by 100. Got it? If suppose RF is not there, RF is 0, so that this term would be completely 0. So it would be simply 81.2 percentage for full wave rectifier, and for this case 40.6 percentage for half wave rectifier. So you can see that for half wave rectifier efficiency is very less as compared to the full wave rectifier. Correct? Okay, now tell me, any doubt up to here? No, no, only 2 or 3 are there in your formula handbook. You have to learn it actually. This efficiency formula is not also not given, PIV formula, IVDC, so it's better. I'm not suggesting you to depend on handbook. Only 1 and 2 formula is given in the handbook, that I'll tell you which formula is given. Okay, you have to cram this table by heart. Okay, wait. uh, Output voltage. In short, I write down output current, output voltage. Okay, so some of the formulas are there which you need to remember. These are the important ones. Some of the formulas are still left, like which you have studied in the BT also. Form factor. You have studied in BT now. Form factor. Form factor is denoted by KF, right? So for half wave rectifier or for the full wave rectifier, form factor wave formula is same. For the half wave rectifier, it is how much? IRMS divided by I average, or we can say VRMS divided by V average. Okay. Now you know the formula. IRMS is how much? I just told you, that is I max by 2, right? So it would be I max by 2, and I average is how much for the half wave rectifier? That is I max by pi, right? I max by pi. So if I'll solve it, I max would be cancelled. It would be how much? Pi by 2. If we'll solve it, then we'll get the value as 1.57. Okay. Now for the full wave rectifier, it is again the same case. I'm writing in a combined way because it's the same. So same formula will use IRMS divided by I average. But now in this case, what happened in the center tab? The formula is of IRMS is not Imax by 2, it's Imax by root 2. Correct? So it would be Imax by root 2 and I average formula is 2 Imax by pi, right? So again Imax would be cancelled out. It will be pi by 2 root 2 and its value is 1.11. That this formula you have studied in BET, right? Okay. Now next formula which you need to remember, that is for ripple factor. Ripple factor is denoted by gamma. Okay. Now for gamma formula is gamma is equal to ripple factor formula is root of kf square minus 1. Okay. Again it would be same for both the cases, but as you can see that form factor value varies, so ripple factor value would also vary. Correct? So you can put it the value and then you will get the final answer. Correct? Now, mm, now you need to learn about the peak factor, right? Remember what was the formula for the peak factor? Peak factor is denoted by K of P and its formula is Kp is equal to maximum voltage divided by the RMS voltage. Okay. So V max will remain as it is, or maybe you can take it in terms of current as well if you want. IRMS by I max by IRMS. VRMS is how much? V max by 2, right? V max by 2. So you can further solve it. Then you will get the value for peak factor in half wave rectifier as 2 and in the full wave rectifier as root 2. Okay, because this cancel, and in this case Vmax V by VRMS. VRMS is how much? Vmax by root 2. So it would be 2. Understood? Hmm? Now tell me, any doubt up to here? Ripple factor formula is same for all of them. And generally they'll ask you the frequency also, output frequency in the maximum of the question. So output frequency is how much? Twice multiplied by the supply frequency in each and every case. Got it? See, this is the question of midterm 2023. They ask you PIV rating of the diode for a full wave bridge rectifier. Okay, so whatever they ask you, if you know the diagram, then it's better to draw the diagram. Okay, it would create a good impression in the teacher mind. So as you can draw it roughly also, no need to draw it in a proper way, like fast you can draw it. Okay. So this is the bridge type rectifier they have given, and at here load was connected. Now they have given the supply voltage, means this is the primary voltage 230 volt and frequency is how much? 50 hertz, right? To a step down transformer with a turn ratio, means 10 turns are there and 1 turn is here, right? So for the calculation we need obviously the secondary voltage V2, but we are having primary voltage V1. So we'll have formula for that which we have studied in BT, maybe V2 by V1 is equal to N2 by N1. This is the formula of transformation ratio. Okay. In the case of rectifier, you'll definitely use this formula if they have given the turn ratio. So turn ratio is like basically N1 is to N2. Okay. So N2 is how much? 1. N1 is how much? 10. V2 we need to calculate. V1 is given 230. Right? So after solving we'll get to 23 volt. So you can do it directly also. If the number of turns is decreasing 10 times, then voltage also must decrease 10 times, right? So you are providing 230 volts, so here we are getting 23 volt, correct? So now this voltage we get it as a RMS voltage, okay? Because in BT also you have studied that maximum of the things, maximum of the calculation we need to do it in the RMS, right? So, but they are asking the peak inverse rating. Peak inverse rating means the maximum voltage. They are asking for the bridge type. For the bridge type, the formula is Vs maximum, right? But we'll have RMS. So we know the relationship between RMS and maximum. What was that? That V2 RMS is equal to, what was the formula? RMS, VRMS, IRMS is Imax by root 2. So VRMS is equal to Vmax by root 2, right? So Vmax divided by root 2. So it would be 23 by root 2. 23 by 1.414. So now tell me what would be the, नहीं मैंने उल्टा कर दिया, sorry. It would be multiplied by root. V2 RMS is this one. So V max is equal to 23 into root 2. So now tell me what is the answer? That would be 32.42 something. So A option is the correct. Got it? See, in this question they have given you the load resistance, Vs max, frequency, half wave rectifier, right? We need to calculate VDC, average load voltage, that is IDC multiplied by RL. RL is 800 ohm. IDC is how much? By pi. This one is Vmax. So we need to calculate Imax by the formula according to Ohm's law. I is equal to V by R. So Vmax divided by RL, right? So that would be 10 divided by 800. So 10 divided by 800 multiplied by 800 divided by pi also. Okay, do it. If we'll solve it, 800 cancel. Answer would be 10 by pi. That would be 3.18 volt. So again, first option is the correct one. Okay. See, in this question, we need to calculate DC output voltage, right? So basically, we need to calculate VDC, and formula for VDC is IDC multiplied by RL, correct? RL they have already given, that is 1 kilo ohm means 1000 ohm. Now we need to calculate IDC. For IDC, let's see the formula for the bridge type. IDC bridge type formula is 2 I max by pi, correct? So we RL. Yeah, now we need to calculate I max because we don't have a I max, right? So how can we calculate I max? Formula for the I max is according to Ohm's law, V max divided by RL, right? We don't have VR max also because they have given us the RMS value always. So first we need to calculate Vmax value. The relationship between is VRMS is equal to Vmax by root 2, right? So VRMS is 220, so it would be 220 multiplied by root 2 divided by RL. RL is 1000, right? So I'm substituting the value 220 multiplied by root 2 by 1000 pi multiplied by 1000. So RL would be cancelled out. 2 into something it will come. The answer is 49.52 volt. Sorry, you have to use secondary voltage ratio also. So instead of 220, it would be 220 by 4 is how much? 55 volt. So here we'll take, instead of 220, we'll take 55 volt, because this is the primary voltage. We need secondary voltage. So instead of 220, take it 55. Then only this answer will come. Okay. Its formula is N2 by N1 is equal to V2 by V1. Every time divide the voltage with the number of turns. Next one is DC power delivered to load, right? So we'll have PDC. PDC power formula is normally I square R. So again we'll take IDC into RL, right? IDC we need to calculate. We have calculated from the previous case. RL we already know, so we can get power, correct? Now calculate it and then tell me the value. See, PDC is I square DC by RL. IDC can we write down VDC by RL? So whole square multiplied by RL. Yes or no? Or we can simply write down power is equal to V square by R. So V square DC by RL. One and the same thing. PDC we have already calculated now. That would be 49.52. Correct? So it would be 49.52 ka square divided by RL. RL is 1000. Simple. To solve it, then we'll get it as 2.452 watt. 2.45 watt base. Output frequency formula. Remember I told you output frequency is 2 multiplied by the supply frequency. That would be 2 multiplied by 50 is equal to 100 hertz. This is the question which you need to do it in your homework. In this everything is same. The difference is 60 sine 100 pi t. So that you have studied in BT, that will have standard equation V is equal to V max sine omega t. So if I'll compare this equation with this equation, then we'll get V max is equal to 60 and we'll get omega is equal to 100 pi. From omega we can get the value of frequency. As you know, the formula for the omega is equal to 2 pi f. Correct? So this is your homework question. Try to do it.